Hello students, welcome to my channel Positron. Dear students, in most of the video I used to tell you all that why the name of my channel is Positron. Once again I'm telling you. Dear students, actually the fundamental particles electron, proton and neutron. In similar way, positron is a every fundamental particle has their antiparticles. In similar way, positron is the antiparticle of electron. Electron is a negatively charged and positron is a positively charged, and mass of electron and positron is same. That is why it is called positron, and that's why the name of my channel is Positron. Simply this name hits me. That's why it strikes me. That's why I keep the name of my channel Positron. Dear students, today's topic is a motion in one dimension, part 3. I have divided the motion in one dimension in 3 parts. In first part, I have discussed displacement, distance, and velocity. In second part, I have discussed the equations of motion, their graphs, how to prove them. And in third, undoubtedly it is a acceleration. Today, I'm going to discuss with you all the acceleration and relative velocity in one dimension, right? Today's topic will be the acceleration and relative velocity in 1D, right? Relative velocity is a bit typical. I will not say typical, but sometimes people get confused in order to understand. So, dear students, relative velocity I have divided into two parts. In first part it is 1D and second part that is 2D. That we will study after studying the vector analysis, when we will study the motion in 2 dimensions. At that time we will study. So I am beginning today's my lecture with acceleration. Acceleration. What acceleration is what? Dear students, acceleration is defined as a rate of change of velocity. This is said to be the acceleration, rate of change of velocity. In many books it's written A is equal to limit delta t tends to 0, delta v upon delta t, right? Dear students, what does mean to this? That A is equal to limit delta t tends to 0, delta v upon delta t. Means delta v upon delta t change in velocity, delta v in delta t time. But what does mean limit delta t tends to 0, delta v upon delta t? Dear students, delta t tends to 0 means time interval is approaching to 0 but not 0. Means you can say that time interval is a very infinitesimally less, very small, extremely small. So delta t tends to 0 but not 0, right? So you can say that let the body is passing through this, and this is a point. What was the acceleration when it was passing through that point? Or what was the velocity when the body was passing through that point? Means at that point body is it takes a few time. It takes a time that is a bit greater than 0, yet it is a very small time when it passes through a point, but it takes a time, and that time is delta t tends to 0 means time interval approaching to 0. Approaching to 0 means it is a very infinitesimally small, extremely small. So limit delta t tends to 0, delta v upon delta t, it is acceleration. It is defining the acceleration at a particular point, and that is why it is said to be the instantaneous acceleration. Acceleration at a particular point or particular instant, and that can be written also as a is equal to dv upon dt. That is, dear students, your syllabus, your part of syllabus contains only the body moving with the constant acceleration. In your syllabus, there is no any single question which comprises that acceleration changes, right? The change in acceleration is not a part of your syllabus, that is beyond of your syllabus. But if you want to know, the change of acceleration is called a jerk. The Indian love cricket, and you know in cricket the bowling there is a word used, jerk, right? So change in rate of change of acceleration is jerk, called a jerk, and not more I'm going to discuss about that. Now dear students, what I have said, that acceleration A is equal to delta V upon delta T, or A is equal to, either you write A is equal to delta V upon delta T, or you write A is equal to dV upon dt. Rate of change of velocity is called acceleration. Dear student, displacement, velocity, acceleration, all these are the vector quantities. Now, dear students, in different conditions, we have to graphically we have to analyze what acceleration probably will be. Now, first I am considering it is a graph between displacement and time graph. Let's discuss in displacement and time graph. Three graphs I am considering. Look here, between x and t, displacement and time. Dear students, one graph is like this, another graph is like this. Let's consider only two graphs. One graph is like this, another graph is like this, and third graph is like this. This. Now, we have to consider what is the acceleration in all these three, right? Dear student, acceleration has two words. One is acceleration and the is a retardation. Acceleration means increasing velocity and retardation means decreasing velocity. You know, if the graph is between x and t, displacement and time, then the slope of curve is actually dx upon dt, and that represents the velocity. Means slope of the curve, when the graph is between x and t, we will consider slope of curve dx upon dt, that represents the velocity, and when the graph is between velocity and time, then slope of the curve will be dv upon dt, and that time slope of the curve will represent the acceleration. Now, dear students, it is between displacement and time, so slope of the curve undoubtedly is going to represent velocity. Now, dear students, I am considering 3 points. This graph is a bit going upward, then a bit flat, and then coming down. So, at these three conditions, I am considering 3 points. Here the slope will be like this, here the slope will be like this, and here the slope will be like this. Now, dear student, tangent, I have drawn the tangent on the 3 points that I have considered. On this graph looking, it has some three portions. One is a going upward, and there is a maximum, and the coming downward. On these three positions, I have considered the 3 points and then drawn the tangent on these 3 points. Now consider the slope of the tangents. You know, if you want to find out the slope of a tangent, draw from that point a line parallel to axis and consider the angle between the x-axis and tangent. So this angle is here theta, right? Now look here, it is parallel to x-axis, so theta equals to 0. Dear students, now this angle is a, you will say it is a minus theta. Anti-clockwise angle is considered positive, clockwise angle is considered negative. Now dear student, look here, it is a velocity is a between, it is a graph between x and t. So the slope of the tangent will be dx upon dt, means slope. This is slope is here. In this case, slope dx upon dt, that is equal to m, and that is equal to tan theta. It is actually, let this angle is theta. So this tan theta is actually representing the velocity here. Here it is a tan theta, then it becomes tan 0, and then it becomes tan minus theta. It means velocity is here positive, then here becomes 0, and then becomes negative. Now look here, velocity is positive, then 0, then negative. It means velocity is decreasing. Velocity is decreasing, means it is a retardation, minus a. It is negative. This is representing negative acceleration. Dear students, in the same, this is just inverse of this graph. It is again plotted between x and d. What happens? Look here. Again, this is coming down a bit minimum. It is minimum and then going upward. The three positions I am considering. This position is this. Now drawing the tangent at these positions. Now consider the slope. This is again minus theta. Here the m is tan minus theta. Or tan minus theta is a what? That is, you know, in this tan minus theta, this is fourth quadrant, and that is in fourth quadrant it is ASTC. ASTC, it is a cos and sec will be positive, so it is a minus tan theta, velocity is negative. Then here again theta equals to 0, and here theta is again positive, right? So here velocity is first negative, then here 0, then positive. When you are moving ahead along the graph, at 3 points you have considered, initially velocity is negative, then it is 0, then it is positive, means velocity is increasing. Dear students, it is an acceleration, right? This was a retardation, it is an acceleration. Now third is a very important, it is a graph between x and t. Look here, the x and t graph is a straight line like this, right? Now dear students, you know, if graph is between x and t, for the velocity we will consider what? Dx upon dt. And dx upon dt is what? Slope of the graph. Slope of this graph is what? Theta equals to 0. Or that is m equal to tan theta means tan 0, and tan 0 is 0. Now slope is 0 means velocity is 0, means it is at rest. And if it is at rest, if velocity is 0, then acceleration is equal to 0 also, because acceleration is a rate of change of velocity. If velocity is 0, then acceleration is 0. There is no need to be confused at all. Now dear students, sometimes how the question is asked. In last video, I have discussed so much about that, how you can plot the graph in different conditions. Dear students, one thing is very important that I am going to discuss with you. Let the graph between acceleration and time is this much. It's a non-uniform motion. A graph between acceleration and time is that much. Like this. It is a graph between acceleration and time is given, right? This is said that using that graph some parameters will be given like 10, 20, this might be meter per second square, and this is a 1 second, 2 second, 3 second, 4 second, it is in seconds. Dear student, such a graph is given between acceleration and time. The question is that what will be the velocity and speed, right? Question is that calculate the velocity and speed of the body, right? From 0 to 4 seconds, right? Or from 0 to 2 seconds, whatever is asked. Dear students, question is that the graph between acceleration and time is given like this, right? Question is saying that find out the velocity and speed from 0 to 4 seconds, right? Dear students, you know A is equal to dv upon dt, or A is equal to delta v upon delta t. In simple term, you can say A is equal to v upon t, or v is equal to at. This one is a very important. This is going to work for you. Dear student, if the graph is given between acceleration and time, then the area of the curve, between graph and x-axis, right? That represent either velocity or speed. If the graph is given between acceleration and time, then area of the curve represent either velocity or speed. If the graph is, again listen, if the graph is given between acceleration and time, then area of the curve either represent velocity or represent speed. If you consider sign convention, right, then it is a velocity, and if you don't consider the sign convention, then it is a speed. If you want to find out from 0 to 4 second velocity, then how will velocity, or you can say average velocity, right? It is not, we are not finding the velocity at a particular instant. We are considering velocity from 0 to 4 second. It means we are talking about the average velocity. Now dear students, again listen my words. If the graph is between acceleration and time, right, then the area of the graph, either represent velocity or represent speed. If you are concerned with the sign, then it is a velocity, and if you are not concerned with the sign, then it is a speed. For example, for our convenience, let's take a very simple curve that will explain everything. Curve is like this. Yes, this is 20, it is representing 20 meter per second, this is 10, and 1, 2, 3 and 4 seconds. Now dear students, it is appearing, these two are the squares, might be squares. Now the velocity will be what? Velocity will be, and let it is a minus 30 meter per second. When you are finding, if the graph is between acceleration and time, then area of the curve, area between curve and x-axis represent either velocity or speed. If you are concerned with the sign, then it is a velocity, and if you are not concerned with the sign, then it is a speed. Dear students, we have to find out the velocity first from 0 to 4 seconds. And already I have said, when you are talking about that velocity from 0 to 4 seconds, then undoubtedly say average velocity we are talking from 0 to 4 seconds. So dear students, velocity is equal to area of this will be, this is 20 and this is 2, so 20 into 2, plus area of this will be, this is 2 to 4, that is 2 into, and this is a minus 30. Because we are concerned with the velocity here, that's why considering here minus. So it is a 40 minus 60 minus 20 meter per second. This will be the velocity, right? And the speed, let it is u. This is a 20 into 2. Again here we are not concerned with the sign, right? It is 2 into 30, so it is a 40 plus 60, that is 100 meter per second, right? This is 100 meter per second. Dear students, important that we discussed the velocity or average velocity or average speed from 0 to 4 seconds. What happens? What will be the average velocity from 0 to 2 seconds? Average velocity and average speed. Average velocity, V average, that is equal to, that is acceleration is 20 and this one is 2, that is 40 meter per second. And average speed, again look here, that is a 20 into 2, that is 40 meter per second, right? If graph between acceleration and time is in either one side, either positive y side or negative y side, negative y axis, then average velocity and average speed will be the same, right? Now dear students, let's discuss further. As I have said, if the graph between acceleration and time, then area between graph and x-axis. If the graph between acceleration and time is given, then area between graph and x-axis represent either velocity or speed. If you are concerned with the sign, then it is a velocity, and if you are not concerned with the sign, then it is a speed. Dear students, in a similar way you can say that if the graph is given, the same graph is between velocity and time, then what happens? Let a graph is this. In the last article, just a moment before, I have said that I have considered a graph between acceleration and time, and I have said that the area between graph and x-axis represent either velocity or speed. If you are concerned with the sign convention, then it is a velocity, and if you are not concerned with the sign, then it is a speed. See, in the similar way, if the graph is between velocity and time, then area between graph and x-axis represent either the distance or displacement. If you are concerned with the sign, then it is a displacement, and if you are not concerned with the sign, then it is a distance. Dear students, this is a graph between velocity and time. Now, if you want to find out the displacement, consider this area, this is a positive, and this area negative. Now, add these two with sign. So, I mean, just subtract this from this, you will get the displacement. And if you add these without considering sign, then it gives actually the distance traveled from here to here, right? So, if the graph is given between velocity and time, dear students, in that cases, what happens? Again, I'm repeating my words. If the graph is given between velocity and time, then the area between graph and x-axis either represent distance or displacement. If you are concerned with the sign, then it is a displacement, and if you are not concerned with the sign, then it is a distance. Dear students, one thing is very important. I have discussed with you all in last video the three equations of motion. That they were v is equal to u plus at. Second one was s equal to ut plus half at square. Third one was v square equal to u square plus 2s. Dear students, in all these three cases, acceleration is a constant, right? Acceleration is a constant physical quantity. In your part of syllabus, that is a constant, it comprises the constant acceleration, right? If a body is falling vertically, then these equations turns out to be v is equal to u minus gt, right? S equal to, S is right s by h, or h equal to ut minus half gt square, and this turns out to be v square equal to u square minus 2gh. Dear students, very important, let a body makes free fall. If it is so, then what happens? Free fall means initial velocity is 0, u is equal to 0. So, v is equal to minus gt. H you can replace by y is equal to minus half gt square, and this is our v square equal to u is 0 minus 2g, or h you can write as a y. This is. Now we have to plot all these. V is equal to minus gt. Dear students, in last video I have discussed this is between v and t we have to plot. This graph represent v is equal to at. This graph represent v is equal to u plus at, right? This graph represent, this is minus u, so it is a v is equal to minus u plus at, right? This graph, and now look here, this graph represent v is equal to, u is a positive, but here acceleration is negative, minus at, and this graph represent v is equal to minus u minus at, right? In this case, you have to make the initial velocity 0, means it will pass through the origin. So the graph of v is equal to minus gt will be like this, right? It begins from origin because initial velocity is 0. So how you can plot? Look here. V is equal to, that is v, that is t, this is v is equal to minus g into t, right? Velocity is here g is a negative, acceleration is negative, so v is equal to minus gt. Because u is 0, that is why we are keeping this to pass from origin. If it is passing through the origin, means initial at t equal to 0, v is equal to 0. right? Dear student, if you have to plot this one, y is equal to half minus half gt square, right? How will you plot? In last video I have discussed a lot with you all. Dear students, if you want to plot, look here. First you should know how to plot the standard equations of parabola. This is what? This represents actually y square equal to 4ax. How will you test? Test only one, that will make everything clear. This is a parabola and it represents the standard equation of parabola. One standard, this is not only one standard equation of parabola is y square equal to 4ax. Dear students, if you put x equals to a, then it is for our convenience we are considering this quantity y square equal to 4a square, or y is equal to plus minus 2a. Means for a value of x equal to a, y has the two values. Yes, it is satisfied, right? The graph is satisfying this equation. It means our equation y square equal to 4ax. I have plotted right. This is what? This is actually y square equal to minus 4ax. Dear student, this is x square equal to 4ay. And this is x square equal to minus 4ay. Now, dear student, we have to plot y is equal to minus half gt square. Y is equal to, y is, just look here, this is y and this is t, right? On the y-axis there is a y, no problem, write it y minus half g. But t is on x-axis, so replace it by x. That will give you more clear concept if you write here x. Now look here, y it is k constant something, g is a constant, so g by 2 is also a constant. I am writing new constant k x square. Now compare which of the graphs resembles to this. Y is equal to minus kx square. Now look here, x square equal to 4ay. 4a if you bring here, it is a y is equal to 1 upon 4a into x square, or y is equal to k into x square. Please look here, x square equals to 4ay, 4a bring here, so it is a 1 upon 4a x square, or y is equal to kx square, and it is a y is equal to minus kx square. So this graph is similar to this, y is equal to minus kx square. So our graph between y and t representing y is equal to minus half gt square will be like this. But dear student, one thing you have to be very clear, that time cannot be negative. If you take this portion of the graph, here time will be negative, so erase this. So the graph will be like this. This is between y and t. Y is equal to minus half gt square. It is a graph of body falling freely between displacement and time, right? And third, you can plot that. How will you plot between acceleration and time? Dear students, if a body is falling vertically, there is no matter what is the initial velocity, what is the final velocity, from what height does it falls, that is all does not matter. It is the acceleration, it is t, and g is a minus 9.8 meter per second square, and g is considered to be constant, and that is minus 9.8 meter per second square, and this will be constant, right? That means if a body is falling freely, then graph between acceleration and time will be this. It represents that velocity of g is minus 9.8 meter per second square, that remains constant. Now dear student, that is all I was discussing about the acceleration. Now today the main topic that I am here to discuss with you are relative velocity in one dimension. In one dimension, relative velocity is just very simple, right? Dear students, let the two bodies are A and B, right? and they are moving with velocity Va and Vb respectively. Location of body A at time t is equal to, you can write body A at time 0 plus Va into t, right? It was the initial point. We are, what is means of this equation? Dear students, SAT means position of A at time t, that is equal to position of A at t equal to 0 plus how much time it travels in t time, that is its velocity is Va with the constant velocity Va and Vb, these bodies are moving. So it becomes this Va into t, distance equal to velocity into time. So this much distance more covers in time t. So at 0 the position was that, and in time t it has covered this much distance. That is why at time t total displacement of this body is this plus this. In similar way, total displacement of t, that is equal to SB naught plus VB into t. If the displacement of A with respect to B, how will you find out? SAB at time t, that is equal to SM minus SB. Dear student, if you subtract these two, you will get SA 0 minus SB at t equal to 0 plus VA minus VB into t. This is a very important quantity. VA minus VB, right? Now, dear students, just erasing this, making clear my code to let you understand how. That is VA minus VB. It is said VAB is equal to VA minus VB. This is also called, right, sometimes VA oblique B, that is equal to VA minus VB. Or you say velocity of A with respect to B, that is VAB, is equal to VA minus VB. Whatever you call or whatever you understand, that is, this is the way. Dear students, VAB equal to VA minus VB. Velocity of A with respect to B, that is equal to VA minus VB. The motive of today's video is to just understand the one-dimensional motion, relative velocity in one-dimensional motion. Question is that what is means of relative velocity? When we say that the two bodies A and B are moving with the velocity VA and VB, then velocity of A with respect to V, VAB is equal to VA minus VB. What does it mean? Actually, dear students, it means VA minus VB, VAB, velocity of A with respect to B, means what will be the velocity of A when the B is at rest. What will, just keep this word in mind, this sentence in mind. It will help you to solve and to understand the solution of even a very typical problems. More oftenly, they are the part of ITs. That VAB, velocity of A with respect to B, that is equal to VA minus VB, means velocity of A with respect to B means what will be the velocity of A when B is at rest. I am just telling you many examples to let you understand. Let that two bodies are, right? They are moving with velocity 90, right? Look here. They are the two bodies. They are moving with velocity 90 towards each other. Now, well, this is A, this is B. What will be the VAB? Means velocity of A with respect to B. I have said that what will be its velocity when it is at rest? You know, it will be 180 km per hour. How? Let they are moving with the velocity 90 and 90, right? And this distance is also 90 kilometer, right? If they are moving with the same velocity, by common sense you can say that they will meet at mid of the point, right? At the mid of these 2 points. And how much distance, how much time each will consider to reach here? That is half an hour. Half hour, right? Look here. The two bodies A and B, the two vans A and B are moving with velocity 90 km per hour towards each other, and they are 90 km apart, and altogether simultaneously they begin to move towards each other. Then undoubtedly they are going to meet at the midpoint, right? They will meet to each other at the midpoint, and the time consumed by them will be half an hour, because it is a 45 kilometer, and with the speed it will take half an hour, and similarly it will take half an hour, means in half an hour they will meet to each other, right? No, dear students, let's apply the relative velocity. VAB is equal to VA minus VB. Look here, VA in this side it is a 90 minus VB. It is opposite, negative x along the negative x axis. That is why consider it minus 90. So it is a 180 kilometer per hour. Dear student, just try to understand this. Now, velocity of this with respect to this is a 180 kilometer per hour. And when you apply the case of relative velocity, I have said that velocity of A with respect to B, if you consider VAB, it means that B is at rest with respect to A. It means in order to meet the B for A, it has to travel this much of distance, right? VAB means velocity of A when B is at rest. If it want to meet B, then it has to travel from here to here this whole much of distance, and then the time consumed, interestingly, time equal to distance upon its a relative velocity with respect to this, that is 180, and again half an hour, that you have got here, right? Dear student, it was a simple case. I have considered what I have considered. Now look here, how relevant is the relative velocity in most of the cases, that this is two vans A and B. They are 60 kilometers apart to each other, right? This one moves with the 30 kilometers per hour, and this one moves with the 20 kilometers per hour, right? They are moving opposite to each other, as simultaneously they begin their journey. This begin to move with the 30 km per hour, this begin to move with the 20 km per hour. Now question is that how much time after they will meet and where they will meet. These two vans are 60 km apart. Question is that how much time after they will meet and where they will meet. Now dear students, again I am considering VAB, velocity of A with respect to B, that is what? That is equal to 30 plus 20, that is just same thing applying, VA minus VB. VA is it is along positive x axis, so this is plus 30, minus VB is along the negative x axis, so it is a minus 20. So 30 plus 20, that is a 50 km per hour. Now dear students, what I have said, if you consider the relative velocity, it means VAB means when B is at rest, the velocity of A will be this, right? If it has to meet, A has to meet the B, because we are concerned with the relative velocity. Now B is at rest, and now if A has to meet to the B, it has to travel this much distance with relative velocity. If you are concerned with the relative velocity, now A has to travel this much distance, but what should be the velocity? Relative velocity of A with respect to B. So time taken will be time equal to distance upon velocity is a 50 km per hour, that is a 1.2 hour, right? 1.2 hour means you will solve 1.2 hour in minutes you can. Now this is how much time it will take. 1.2 hour, right? Now, dear student, where will they meet? Question is that where will they meet? Now, take their individual velocity this time. In 1.2 hour, how much it will travel? S equal to, in 1.2 hour, it will travel 30 into 1.2. That is a 36 kilometer. And how much it will travel? SA and B will travel 20 into 1.2, that is 24 kilometer. Interestingly, if you add these two, you will get the 60 kilometer. It means now first we have applied the relative velocity and we got that time 1.2 hour. After that they will meet to each other, right? It is 1.2 hour after they will meet to each other. Now question is that where will they meet? So for that, in 1.2 hour, how much this will travel? Now you have not to apply the relative velocity. Now you have to apply the individual velocities in 1.2 hour. Actually, what is in realistic? It is relative velocity. Why do you apply? In order to solve the problem easily. But actually, they are not. They are traveling with their own velocity. That is why how much distance it will cover in 1.2 hours. You have find. In 1.2 hours, its individual velocity I have considered and got this, and ultimately if you sum, you will get the 60 km per hour. Dear student, it was a relative velocity case. For example, for the relative velocity, like S equal to ut plus half ad square is your equation. If the two bodies are A and B, right, then you can apply. This formula can be converted into relative velocity form like this. SAB means displacement of A with respect to B, that is UAB into T plus half AAB into T square. Right? Dear students, very important. Actually, whenever we are conceived, just wait please. Dear students, whenever we are concerned with the motion, always there is a concept of frame of reference, because motion is not absolute quantity. You cannot say a body is in motion or a body is in rest. Now, it is the observer, the position, the status of observer will define that whether a body is at rest or it is moving. For example, you are watching my video, I'm sure, damn confident you would be sitting having book and pen in your hands and you will be concentrating on the videos, right? You are at rest and me is also at rest, you can say. Look at a car which is going, right? And two people are sitting in the car. The car will appear to you moving, right? And the two persons sitting in the car will also be moving with respect to you. But look, those two people who are within the car, they are at rest with respect to each other. It means observer has changed. The status has changed. The same car, same two people boarding car were moving with respect to you when you are studying and watching my videos in your room. But those two people who are sitting in the same car with respect to each other, they are at rest. It means motion is not absolute quantity. You have to define a frame, observer with respect to which motion has to be defined, and that place, person or the object with respect to which motion is defined is called frame of reference. Dear student, in some cases, look here, very interestingly, a graph between displacement and time is this. Now look here. These two graphs are parallel. What it is representing? It is between S and T. The slope of the graph will be ds upon dt, and that will represent the velocity. And both the graph has the same slope. They are parallel. It means they have the same velocity. It means at initially t equal to 0, their displacement was that. At t equal to 1 second, the displacement will be same. At t equal to 2 seconds, their displacement will be same, right? Now dear students, what happens? A graph is like this and that is like this. What does it mean to it? Look here, again it is a between displacement and time, right? This shows that both are moving. This is the origin, displacement is up to origin, means both are moving with positive velocity away. Look here, their slope, velocity is what? ds upon dt, and this is slope of this graph is let theta 1 and this is theta 2. It is clear that theta 1 is greater than theta 2. Dear students, both are moving away from the origin in the same direction, and initially look here, and this angle is greater, means tan theta 1 is greater than theta 2. So you can say tan theta 1 is greater than tan theta 2, means velocity of first one is greater than v2, right? Initially the displacement was that this was ahead to, it was a, it was b was ahead to a, because that initially at t equal to 0 the displacement of b with respect to origin was that much and displacement of a with respect to origin was that much. It means b was ahead to a, but a was traveling faster than the b. That is why that separation was decreasing. At this particular time they meet to each other and then b crosses the a, right? This is the way. And third graph you can consider like this. A body is moving in this way and another is moving in this way, means these two bodies are moving apart from each other, right? They are moving opposite to each other, right? And their separation is continuously increasing. This is many kind of the graph, relative velocity. Dear students, I have discussed one case I would like to discuss with you all more. This is a case of relative. Actually, the simplest form of relative velocity in 1D when you are discussing sometime. Question of river and boat in 1D is what? I will not say it is a relative velocity. Let the stream is flowing like this, velocity u, and your boat is, you are sailing your boat in the same direction. Then you write the velocity of boat v plus u, that is a down to the stream. This is called down to the stream. And now look here, it is the velocity of boat. And river, you are moving, river is flowing in this way, you are moving opposite to the that is a river, and this is called up the stream. And in that case, this is river is opposing your velocity, so it is a v minus u. And when you are down the stream, velocity is v plus u. And many simple problems can be solved using this. Dear students, least but not last, after every my videos, I used to tell you, I used to request you that if my videos are going to be fruitful to your studies, please and please share my videos, like my videos, comment my videos, and put the bell icon so that you can be notified my next videos about. And next video undoubtedly would be about the vector analysis. That's going to be very important. So meet you in next video. Bye.